This is practice test number 4, and we are working on number 8. Number 8 is really based on number 7, and so I will read number 7 and then we can go to number 8. Number 7 said a study was conducted on the amount of money spent by customers for lunch at a local restaurant. The average cost of lunch X-bar was $34.55 for 25 customers, with a standard deviation of $10.50. Assuming a normal distribution, construct a 95% confidence interval estimate for the average cost of lunch for all the customers, and we're asking for the population around the population mean mu. And we did calculate this in the previous problem using this formula at the top of the page, and you can refer to that video if you need to. But down in number 8, we are told if the number of customers is increased to 100, construct a 95% confidence estimate for the above study. Assume the average cost of lunch and the standard deviation are the same. And so what has changed here in number 8 is the number of customers, which is the n, and the n is now 100. And what that is going to change is the value of t in our formula. So to use the t-distribution table, we first calculate the number of degrees of freedom, which is n minus 1. In this case, it would be 100 minus 1, which would be 99. And then we would go to the critical t table or the t-distribution table and go down the column for degrees of freedom. And in that table, we're going to have to use 100, which is the closest degrees of freedom, come across to the 95% confidence interval column, and we will find the t value there of 1.984. And that's the value that we're going to use now in this equation. So we're going to do the same calculations as we did in number 7, except with a different t value. And you can see how I plugged in those values here, the x bar 34.55 minus the t value times the standard deviation divided by the sample size, which in this case is 100. And both sides of the equation are similar. The only difference is you have a plus on the right-hand side and a minus here on the left, but the values are all the same on both sides. So as you do the calculations, you should come up with this confidence interval right here. And you'll notice that this confidence interval is higher, or tighter rather, than the confidence interval up here. It's closer around the mu, a smaller confidence interval. So the question on letter B is, how has the confidence interval changed and why? And the answer is that a larger sample size leads to a tighter confidence interval. The larger sample size gives us a more accurate estimate of the population mean, mu. So that concludes number 8.